So let's wrap up our discussion on photosynthesis. And up to this point, we've been focusing mostly on the light reactions, and photosynthesis, we have one more step that's got to happen. And so we're going to utilize the ATP and the NADPH that we created during your light reactions, and they're going to be shuffled over to the Calvin cycle, which is going on out in the stroma of your chloroplasts rather than across the thylakoid membrane like your light reactions are. And your Calvin cycle is going to utilize that ATP and the NADPH that we created during your light reactions to go through carbon fixation, where we're going to take CO2, fix it into chains of carbon, and what we end up producing at the end of one turn of Calvin cycle is a molecule down here called G3P. And G3P is a sugar building block that we can utilize in your plants to then build glucose, or it can also be modified and built into amino acids, built into fatty acids, depending on what the needs of the plant are at that period in time. Just like your citric acid cycle that happens in your mitochondria during cellular respiration, your Calvin cycle is a cycle built to not only get some products out of it, but also to regenerate the molecules that we need to continue making sure the cycle spins. Now keep in mind that we can talk about this as your Calvin cycle, just like Krebs was named after his cycle. Calvin's cycle comes from Melvin Calvin, who happened to figure this one out as well. All right. So how does this all work? Well, we're going to take in your CO2 here, okay? And so we're going to actually look at the Calvin cycle in 3 steps. So phase 1 here, phase 2 here, and phase 3 over here. And phase 1 is truly your carbon fixation. We take one CO2 in at a time, utilizing an enzyme called Rubisco. And that Rubisco is going to help to attach the carbons from CO2 into this short-lived intermediate, which is ultimately going to come into phase 2, which is the reduction. Now we can only bring in one CO2 at a time, so this particular piece of carbon fixation happens to occur 3 times before we can move into phase 2. Okay, so just keep that in mind. With the help of that Rubisco, though, we create this particular short-lived carbon intermediate. That gets shuffled down then once we've got those 3 CO2s in, which, oh, by the way, is also where we release the oxygen that you and I are currently breathing. We're going to come down into phase 2, which is your reduction phase. And just like I said with the Krebs cycle, don't get lost in all these intermediaries, okay? You do not need to be aware of anything outside of Rubisco, the CO2, and the G3P, and then just have a basic understanding of what's going on here. So don't get lost in this bisphosphoglyceraldite. You don't need to know that. It's okay. So the CO2 comes in, we fix it using Rubisco. We end up down here in a reduction phase, all right? So we're going to utilize some of that ATP and use that energy to do some rearranging of carbons, tacking on phosphates, removing them, so on and so forth. Same deal with the NADPH, okay? And what that spits out here then is the actual G3P molecule that we need. Okay, now some of that G3P goes off and becomes the glucose and other organic compounds that your plants need. We're also going to use some of the G3P, and that's going to get shuttled through this regeneration phase because I need to get back that Rubisco. Okay, and right now it's currently being lost in sub-pieces in here. So we're going to shuttle some more of that G3P back up here so that I can recreate that RUBP, which then is going to get me my Rubisco back, so the cycle continues to happen. Okay.